Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
This is the first problem in the 7th homework, and it's got a box with 8 vertices, and the dimensions are given in feet, and there's a force going diagonally. It's got 633 pounds acting diagonally from point A to point D. And so let's type in the coordinates. Let's start with the furthest coordinate. It's E, and we're going to put it in feet. 2.4 feet in the X, 6 feet in the Y, and 3 feet in the Z direction. And I'm not going to print it out. So let's do C after that. C is going to be and it doesn't have an X dimension, so C is that. D is going to be it doesn't have a Y dimension either, so it's going to be that, and B is going to have no Y dimension, so it's going to be that. Now A is going to have no height, and F is not going to have any height either, and O has no height, and it's the origin, and G is going to be following B, and G is this guy right here, and G is 0, right? Yeah. Okay, so we have all the points. Now we are going to find the line AD. AD is D minus A. Pretty simple. I want to see this one. Yeah, so D minus A. So UAD is actually AD divided by norm of AD. And that should give me the unit vector AD. Okay, so FAD, I'm not going to call it F because we already have the term F in here. So FAD equals to 633. That's the number of pounds. And we're going to do a scalar multiplication with UAD. And that should give us the F, and let's print that out. So this is our F. Next we need so the question is, now that we have found F, the question is we have to find the moments of F along about these lines. So OC is this line over here, and let's get M around the point O, and that is going to be cross. It's going to be A F A D. Yeah, so it's basically this point right here, from this point to this point. That's the radius, and so that is the vector for that is A, and we have MO for, and that is this number over here. It's pretty big. Now that we have found the moment around O, what we're going to do is we're going to do a dot product for OC, and this. So M OC equals to dot C minus O divided by norm C minus O. How is that? That's the dot first part of the dot product. The second part of the dot product is M O. And let's see what that number is. It is minus 572. So we are looking for the magnitude, so we need 572.1638. And I'm not going to write anymore. No, okay. So next is, oh, that is in feet pound because we haven't changed any. Next is OD. So we can use MO for this again, and so MOD equals to dot. Well, let's copy this one. MOD is dot D minus O, and MO, and the answer is 0, which is correct because OD, D, it crosses through D, so it should be 0. Next one is CD. So let's for the fun of it, let's find out what MD is. MD is actually it's going to be like MO, so I'm going to write MD over here, and it is going to be A minus D over here, because we need the distance from D to A. D to A, yeah, that is correct, and that should be exactly 0 if we're correct, and that is 0. So we don't need to go any further, but the 0 times dot product with a 0 vector is going to be 0. So we don't need to do that, but let's do that. MCD. So it's this one. CD, C, and D, and that is 0. Okay. So next one is BC. So we can do C now. C, and BC is going to be BC, B, C. It's 593.9452. Okay. DE, we're going to use MD for that, and E it's going to be 0, but let's do it. DE, D minus E, D minus E, and we have D over here, so we got that covered. And that's 0. And next one is CG. And that's G, C. That is correct. So that is going to be 0. And FG. So we need MF. So let's find MF. MF. Okay, and then we're going to find MFG, FG, F, F, 593, 593.9452. And that is the final answer. Let's check the answers, and they're all correct. So great.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.